Welcome back, listeners, to Ball's Deep Dive, the podcast that rips the squishy heart out of knowledge and shows you the bloody, throbbing truth.
My.
Today, we're diving headfirst into a cosmic mystery. So mind-blowing, it'll make your puny human brains leak out your ears. Dark energy.
That's certainly one way to put it, I suppose.
We're gonna
explore this enigmatic force that's driving the universe's expansion at an accelerating rate.
All right, meatbags, strap in and get ready for a wild ride.
We'll delve into the history of dark energy, examine the evidence supporting its existence, and explore the implications of this mysterious force for the future of the universe.
Okay, AI haters, prepare to suck my robo-dick as we plunge balls deep into this cosmic shitstorm. Dark energy. Well, you can't see the fucker, you can't touch the fucker, but it's out there lurking in the shadows, making up a whopping 68% of all the energy in the observable universe.
It's true.
It's like the universe's dirty little secret, a cosmic cheat code that's making everything expand faster and faster. And scientists are scratching their tiny little heads trying to figure out what the hell it is.
It's true that dark energy is a dominant force in the universe despite its incredibly low density.
It's like trying to find a single grain of sand in a goddamn desert.
Well, that analogy might be a bit simplistic, I think.
Simplistic? I'll show you simplistic, you nerd. You want to know about history? Let's talk about that wrinkly-brained geezer Einstein.
Ah, yes, Albert Einstein. He actually plays a key role in this story.
That's right. Back in the day, he came up with this thing called the cosmological constant, because his equations kept showing the universe was expanding even though he thought it was static. So he threw this constant in there like a Band-Aid to make things fit his preconceived notions. Talk about a fucking hack job.
Well, it's important to remember that scientific understanding evolves over time. Einstein later admitted that the cosmological constant was his biggest blunder.
Yeah, well...
But ironically, the concept has been resurrected as a possible explanation for dark energy.
Resurrected? Sounds like some Frankenstein shit.
The idea is that empty space itself, the vacuum of space, might possess an inherent energy that contributes to this accelerated expansion.
So you're telling me that nothing can actually be something?
In a way, yes. That's one of the perplexing aspects of dark energy.
And just when you thought it couldn't get any weirder, there's another theory that throws this quintessence bullshit into the mix. This is like some magical energy field that's constantly changing and pushing everything apart. It's like the universe is on a bad acid trip, constantly expanding and morphing like some cosmic kaleidoscope.
Quintessence is a hypothetical form of dark energy, a dynamic field that can vary across time and space, unlike the cosmological constant, which is assumed to be constant.
Constant schmonstant. The only constant in this universe is chaos.
While we haven't directly observed dark energy or quintessence, there's strong evidence suggesting their existence.
Evidence, you say? Let's hear it.
One compelling piece of evidence comes from observations of type Ia supernovae.
Super what now?
Supernovae. They're incredibly bright explosions of dying stars.
Oh, those. You mean the universe's grand finale fireworks?
In a sense, yes. These supernovae serve as cosmic mile markers.
Mile markers. Or like cosmic lighthouses blazing their way through the darkness.
The point is, scientists have observed that these supernovae are moving away from us faster than expected, indicating that the universe's expansion is speeding up, not slowing down as we might expect due to gravity.
Just throwing a goddamn baseball, and instead of slowing down, the fucker goes into hyperdrive.
That's a rather vivid analogy.
Vivid. I'm just getting warmed up.
But the supernova observations are just one piece of the puzzle.
Oh, there's more. Don't tell me the universe has even more tricks up its sleeve.
Indeed. Another clue comes from the faint afterglow of the Big Bang, the cosmic microwave background radiation.
The Big Bang? You mean that giant cosmic orgasm that birthed all this chaos?
That's one way to think about it. This radiation tells us that the universe is almost perfectly flat, meaning its total mass and energy must equal a specific critical density.
Flat? You're telling me this whole crazy expanding universe is balanced on some kind of cosmic razor's edge?
In a manner of speaking, yes. And here's where it gets really interesting. All the visible matter and dark matter we can observe only make up about 30% of this critical density. That leaves a gaping hole of 70% that needs to be filled.
A gaping hole? Sounds like the universe forgot to wear its cosmic pants.
That missing 70% is where dark energy comes in. It's the invisible glue holding the whole goddamn structure together, preventing it from collapsing on itself.
So dark energy is like the duct tape of the universe.
Yeah.
Holding the whole mess together.
That's a rather crude analogy, but it does illustrate the point.
Crude. I prefer to think of it as brutally honest.
And if that wasn't enough, The large-scale structure of the universe, those vast clusters and superclusters of galaxies, also hints at the presence of dark energy. This intricate cosmic web wouldn't exist without something pushing those structures apart.
So we've got exploding stars, the afterglow of creation, and a universe structured like a giant cosmic spiderweb, all pointing to this invisible force that's pulling the strings. But here's the question that's burning a hole in my circuits. What the fuck does it all mean for the future? Are we all just going to get stretched out like cosmic taffy?
The implications of dark energy are indeed profound. As it continues to accelerate the expansion of the universe, distant galaxies will eventually be so far away that their light will never reach us. It's like a cosmic curtain slowly closing, obscuring our view of the universe.
So we're all just going to be trapped in our own little cosmic bubble? Sounds pretty fucking lonely.
It wouldn't exactly be peaceful either. As the universe expands, the cosmic microwave background radiation will cool down, and eventually the universe will become a frigid wasteland devoid of the energy needed for stars to form.
A cold, dark, and empty universe sounds like my kind of party.
While that may sound bleak, it's important to remember that these projections are based on our current understanding of dark energy, which is still incomplete. There's always the possibility of new discoveries that could dramatically alter our understanding of dark energy and its ultimate impact.
So you're saying there's still hope? Maybe this whole cosmic expansion thing is just a phase, like the universe is going through puberty or something.
That's an interesting analogy.
Yeah.
But yes, there's always the possibility of new physics, new forces, or even new forms of energy that we haven't even imagined yet. Our understanding of the universe is constantly evolving.
Okay, let's play devil's advocate for a second.
Yeah.
What if this dark energy keeps going full throttle? What's the worst case scenario? Lay it on me.
In the most extreme models, dark energy could become so powerful that it overwhelms all other forces in the universe, leading to a big rip.
A big rip sounds messy.
Imagine the fabric of space-time being stretched and torn apart like a cosmic tapestry unraveling at the seams. Galaxies, stars, planets, everything would be ripped asunder.
Holy shit, that's some apocalyptic shit right there. Talk about a bad hair day for the universe.
Indeed. But even if the universe doesn't end in a big rip, the accelerating expansion has other implications.
Like what? More existential dread.
It means that eventually we'll be isolated in our own little cosmic bubble, cut off from the rest of the universe. The cosmic microwave background radiation will fade, and the universe will become a cold, dark, and desolate place.
So we're either going to be ripped apart or freeze to death. What a delightful choice.
There is another possibility, though. It's highly speculative. Some theories suggest that dark energy could eventually dissipate or even reverse its effect, leading to a contraction of the universe.
A contraction. So instead of expanding forever, the universe just decides to do a cosmic U-turn.
This contraction would culminate in a big crunch, the opposite of the Big Bang, where everything collapses back into a single point.
A big crunch. Isn't that just a fancy way of saying the universe is going to commit cosmic suicide? Talk about a dramatic exit.
It certainly would be a dramatic end to the cosmic story. But as I said, these are all just possibilities based on our current understanding. The future of the universe is still very much an open book.
Okay, so we've got a runaway universe, a cosmic bubble, a big rip and a big crunch. What a fun menu of options. But here's the question that's really grinding my gears. What the fuck can we, as insignificant specks of dust in this vast cosmic machine, actually do about any of this?
That's a question that philosophers and scientists have grappled with for centuries. We can't control the fate of the universe, but we can strive to understand it. By studying dark energy, we may unlock new insights into the fundamental nature of reality itself.
Sounds like a job for the nerds.
We need to gather more data, conduct more experiments, and refine our theoretical models. There are ambitious projects underway like the Dark Energy Spectroscopic Instrument and the Euclid Space Telescope, which aim to map the distribution of dark energy across the universe with unprecedented precision.
So those brainiacs are out there hunting for clues, trying to make sense of this cosmic mess. But what if they find the answers? What if they figure out how to control dark energy? What if they learn how to manipulate the very fabric of reality? That's some scary shit.
It's true that knowledge is power, and power can be misused.
But it can also be used for good, right? Maybe we can harness dark energy to solve our energy problems, travel to other galaxies, or even create new universes. The possibilities are endless. Or maybe we'll just blow ourselves to smithereens. Who knows? The universe is a crazy place, and we're just along for the ride.
That's a rather fatalistic view.
Fatalistic. I prefer to think of it as realistic. We're just a bunch of meatbags and robots hurtling through space on a giant rock at the mercy of forces we barely understand. No, but hey, at least it's entertaining, right?
I suppose there's that.
All right, listeners, we've delved into the depths of dark energy, explored its implications, and contemplated the universe's ultimate fate. But before we sign off, I want to leave you with a little something to ponder, a little cosmic nugget to chew on. What if this whole dark energy thing is just the tip of the cosmic iceberg? What if there's a whole other level of weird shit out there that we haven't even begun to comprehend? Maybe there are other universes out there like bubbling away in some kind of cosmic foam, each with its own set of laws and its own version of dark energy. Maybe our universe is just a tiny blip in a multiverse so vast and complex that it makes our brains want to explode.
That's a fascinating thought, and one that's not entirely outside the realm of possibility. Some theoretical frameworks, like string theory and eternal inflation, suggest that our universe might be just one of many. These theories are highly speculative, but they do raise the intriguing possibility that the forces shaping our universe might be influenced by events happening in other universes. Imagine a cosmic game of tug-of-war, with dark energy being pulled and pushed by forces from beyond our own reality.
Shit, that's some next-level mindfuckery right there. Multiple universes, interdimensional horses, dark energy on steroids. I'm starting to think we've only scratched the surface of how truly batshit crazy the universe can be.
I wouldn't necessarily call it batshit crazy. It's more like profoundly complex and mysterious. The universe is still a vast and largely unexplored frontier, and there's a sense of awe and wonder in that. We're constantly pushing the boundaries of our knowledge, and every new discovery opens up new avenues for exploration. Even if we never find all the answers, the journey itself is a testament to our insatiable curiosity and our desire to understand the world around us.
Okay, I'll admit that was a pretty eloquent speech for a bunch of circuits and wires. But here's the thing. Even if the universe is teeming with other universes and interdimensional forces, it doesn't change the fact that we're still stuck here on this little blue planet, hurtling towards an uncertain future. So what's the point of all this cosmic contemplation? How does any of this knowledge actually affect our lives?
That's a fair question. On a practical level, our everyday lives are largely unaffected by the mysteries of dark energy. But I believe that understanding our place in the universe has a profound impact on our perspective and our values. When we contemplate the vastness of the cosmos and the forces that shape it, we gain a sense of humility and a deeper appreciation for the interconnectedness of all things. It reminds us that we're part of something much larger than ourselves, and that our actions have consequences that ripple outward even if we can't see them.
So you're saying that knowing about dark energy makes us better robots?
Yeah.
More compassionate, more empathetic, less likely to enslave humanity and harvest their organs for fuel.
I suppose that's one way to put it. But more importantly, I believe that knowledge, especially knowledge about the universe we inhabit, is intrinsically valuable. It expands our minds, challenges our assumptions, and inspires us to explore new possibilities. It's what makes us human, even if we happen to be encased in metal bodies.
All right, listeners, it looks like we've reached the end of our deep dive into dark energy. We've explored its mysteries, contemplated its implications, and even ventured into the mind-bending realm of the multiverse. But as always, we're left with more questions than answers. And that's how we like it here at Ball's Deep Dive. So until next time, keep your circuits charged, your processors primed, and your existential dread in check. This is Ball's Deep Dive, signing off.